try to balance the following chemical reaction. Now we have known that how to say that whether a given equation is a balanced or not. If the number of atoms on left side of the arrow and right side of the arrow are equal, then we say it is a balanced equation. When it is not, then we say it is a skeletal equation. Okay. Now let's try to balance this equation, this particular equation. There are few steps that should be followed in order to balance the given skeletal equation. We call this method, like the steps that we have written and that we are going to follow are the steps for the method called hit and trail method. In this method, we just estimate the number. We just estimate the number in order to balance the equation on both the sides of the equation. First, let's know the various steps and parallelly compare it with the given equation. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. First, if you're given a reaction, we should not change anything in the reaction. Like you have Fe. We are not allowed to change it as Fe2. Okay, right. Like writing it in the subscript, you should not write Fe2. We should not change in that way. So just draw boxes around this equation, around every element and every compound. Draw these small boxes so that will not do any changes in this. Now the second step is that list the number of atoms of different elements present in the unbalanced equation. You can call it as an unbalanced equation, or you can even call it as a skeletal equation. Okay, now on the left hand side and on the right hand side, let's write the number of atoms. If you see here, let's compare it with this table as well. Here on the right hand side, we have number of iron, that is 3, and on the left hand side it is 1. It is 1. And hydrogens on the right hand side we have 2, and on the left hand side also we have 2. On the right hand side we have 4 oxygen, and on the left hand side we have only 1 oxygen, 1 4. Right? Now coming to the next step. What is the first step? You need to draw boxes. What is the second step? Count the number of atoms on the left hand side and also on the right hand side. It is often convenient to start balancing with the compound that contains a maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has a maximum number of atoms. Using these criteria, we select Fe34 and the element oxygen in it. Now, when we go through this table you could find which has more number of atoms. 4 is the greatest number, and it is nothing but oxygen. So oxygen is present in where? It is present in Fe34, that is in the product side. So we choose oxygen first to get balanced. Okay, so in the reactants, in which compound we have oxygen, we have in H2O, that is 1. In products we have it in Fe3O4, that is 4. In order to balance, multiply 1 with 4 in order to get 4, so that we get 4H2O. Finally we get 4H2O. So the oxygen got balanced. So what is the step 3? The step 3 says that in order to balance, choose a particular element which has more number, which has a maximum number. In this case, oxygen has 4 atoms, so that we have chosen oxygen. You might choose hydrogen if it has 8. So what is the maximum number? We need to choose that. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds. So we cannot change the formula of the compound. Okay, we should only change the coefficients of the compound but not the formula of the compound. Right? So for example, to balance oxygen atoms, we can put the coefficient 4 as 4H2 and not H2O4. H2O4 in the sense you are changing the formula of the compound, so that the reaction may also change in some cases. Now the partly balanced equation becomes, this is a partially balanced equation. It's not fully balanced. It's not fully satisfied. The next step, Fe and H atoms are still not balanced. Once again, if you look at the table, oxygen becomes 4, hydrogen become 8, because you have added 4 here. You will get 4 into 2, 4 times 2 gives rise to 8 oxygens. So again something is missing and not balanced, right? Now let's balance the hydrogen atoms in the partially balanced equation. Initially there were 8 and in product there were 2. You'll get 8 when you multiply by 4. So 2 times 4 gives rise to 8. So in the product side, multiplying 2 with 4 gives rise to 8, right? So here 8 hydrogens, here 8 hydrogens, and here 4 oxygens, and here also 4 oxygens. Hence we have balanced hydrogen and oxygen in the given equation. Coming to step 5. That is, examine the above equation, pick up the third element which is not balanced. You find that only one element is left to balance. What is that element? That is iron. So in reactants we have 1, in products we have 3. So in order to get 3 on the reactant side, multiply 1 with 3, you get 3. So we can say that multiplying the iron with 3, you get Fe3. But you should not write it as Fe3. You should write 3 times Fe. So 3 times Fe is different and Fe times 3 is completely different. They both make a difference, right? So finally, to check the correctness of the balanced equation, we count the number of atoms on both sides. Now, coming to counting the number of atoms, on the left hand side, that is on the reactant side, we have 3 atoms of iron. Here we have 3. Number of hydrogens, 8. Number of hydrogens, 8. Number of oxygens, 4. Number of oxygens, 4. Hence, the given equation is balanced. The number of atoms of the elements and on both sides of the equation are equal. This equation is now balanced, and this method of balancing the chemical reactions is known as the hit and trail method, as we make trials to balance the given equation by using the smallest whole number coefficient. And another thing we need to remember is that the equation should be in the smallest whole number coefficient. Smallest, that means there should be no common factor between the coefficients in the reaction. Only the common factor should be 1. Other than 1, there should be no. Suppose we have here 8. In this it's not possible. But something which is actually the multiple of 3 and multiple of 4. Let's take 12. Here we have 12, here we have 12, here you have 12, and here you have 12. For example, I'm just taking it as an example. It's not mandatory. Now, all the 12 should be cancelled and the basic equation will contain all as ones. So, that is a basic equation. Step 7 is that the writing symbols of the physical states. We know physical states, like we have 3 physical states, that is solid, liquid, gas, and we have another one called aqueous. Carefully examine the above balanced equation, that is 1.9. If you see this equation, does the equation tell us anything about the physical state of each reactant and product? Obviously no. So the information has been given in this equation about, no information has been given in this equation about the physical states. So in order to make a given chemical equation more effective, more informative, then the physical state should also be mentioned in the formula itself. The gaseous, liquid, aqueous, gases, liquid, aqueous, solid states of the reactants and products are usually represented by the notations G, L, aqueous, S, etc. Now, the word aqueous is written if the reactant or the product is present in a solution. Now, if you see, here the iron is solid, water is gas. In this reaction, you have taken water in the form of vapor. You need to understand in that way before. Like when you don't have any of the solid, liquid or gas, would you know that the water is liquid or gas? No. So by assigning the symbols of their physical states, it is very easy to know that yes, we have used vapor form of water to do this experiment, and here we got solid, here you got gas. Note that the symbol G is used with H2O to indicate that the reaction water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes you also use the conditions like temperature, pressure, catalyst, etc. to make the equation more effective and more informative. For example, in these two situations, carbon monoxide, hydrogen, CH3OH under a great pressure of 340 atm, right? Now you can say, is this a skeletal equation or a balanced equation? Yes, it is a balanced equation. 1 carbon, 1 carbon, 1 oxygen, 1 oxygen, 4 hydrogens, 3 plus 1, 4 hydrogens. So this equation is balanced. This is a photosynthetic equation, right? We are familiar with this equation, photosynthetic equation, 6CO2 plus 12H2O, C6H12, glucose plus oxygen plus water. Using these steps, we can balance equation 1.2 given in the text earlier.